So this is an interesting problem from NCERT Exemplar. The topic is capacitor. And I was very intrigued by this question because I saw a lot of solutions, including NCERT solution, and I disagree with most of the solutions. Okay, and here is my take on how we should be solving this problem. Now, in this problem, if you notice, what you have is two capacitors, and one capacitor is filled by a dielectric. Okay, so let me just fill it with a dielectric. Okay, the only thing is this dielectric, the dielectric is not a constant but is a variable. So K is written as alpha into U, right, where U, okay, is the applied voltage, and alpha is some number which is equal to 2 per volt. Okay, so which means K is not a constant, K is a variable. It's a variable. The second capacitor, okay, has no dielectric but is charged to some potential. Okay, so this is the second capacitor, I'm sorry, is charged till the potential of 78 volts. And it's a similar capacitor, which means the capacitance is identical. Okay. After you charge this capacitor, which is this capacitor number 2, you connect this to the uncharged capacitor, which is this. Okay, maybe you connect it through some conducting wire so that the charge can flow. And this is uncharged to start with, and this is charged to start with, right? So let's say the charge on this will be Q is equal to 78 multiplied by C. This is the total charge on the second capacitor. The first capacitor has variable dielectric field. I will just repeat. The capacitance is same. Let's write the situation when we connect them. At a certain point, the potential of these two will become equal, which is, say, V dash and V dash, and no further movement of charge happens. So let's say the charge which is left on this is Q. Say let the charge on this be Q, and what is balance here is Q minus Q. Okay, where Q is this number, the total charge. The charge traveled, and after some time the potential of this first capacitor with variable dielectric increased, and then it attained a potential V dash, and both became equipotential and no further movement of charges. At this point we can say V dash, which is the capacitance potential for each one of them, can be written as Q minus Q, right, divided by C. And the second one also, okay, since this was uncharged, gradually it received small amount of charges coming from this particular capacitor, right? So this capacitor kept on sending and charges on this capacitor, and the potential of this capacitor kept on increasing. So gradually it increased, and then it reached a certain value. My problem is, if I have to find the equation for this particular capacitor which was uncharged, and I take it to a level of V dash, for example, right, and Q minus Q is the first one, we have solved it. If you write the second one, right, the second one, if the potential of the second one changes, we started from zero potential, right? It was at zero potential, and as the charge started flowing, the potential rose. Say for example, by dq, the potential rose by dv. Okay, that's your new potential. So I am saying the dq charge which is coming will follow this rule, C multiplied by dv. Okay, now this C which we are referring to, right, is actually Kc, right, because it has a dielectric which is K times C. They are similar, but it has a dielectric. I'll just correct myself. This was Kc. I will write it as C first one with the dielectric. So let's say this is Kc into dv. When a small charge dq flows from the charged capacitor on top of the first capacitor with dielectric, the potential of the first capacitor, the first capacitor is this one, increases by an amount of dV. I have to find out how much charge finally is attained by this particular capacitor with the dielectric when it attains a potential of V dash. But I have a catch here that K is variable, right? So I will write dQ is equal to alpha V. Instead of U, I'm using the value V, right? So this particular value, which is my K, the dielectric constant, is being written as alpha V. This is my dielectric constant into C into dV, right? This is my instantaneous charge on the first capacitor with variable capacitance. So my Q, if it starts from 0 and it reaches Q, becomes integral of dQ and integral of alpha V dV and C, right? And if you notice, if you do the derivation of expression of charging of a capacitor where you get energy as half CV square, you get a half there also, right? Let's do a fair comparison. So you have the answer as C alpha V square by 2, and you are charging it till the equipotential V dash. So this is your Q, the charge which has come on it when it reaches V square, and let's say this will become C alpha V dash square by 2 minus 0 because there is no value here. So your charge after a certain time will become on the capacitor with dielectric to be C alpha V dash square by 2. For the other one, the equation I have written is here, right, which is the charge which was the capacitor responsible to provide the charge. V dash is equal to Q minus Q upon C. If you notice these two equations, and look at the question. What is the question? The question says you have to find the final voltage on the capacitance and their equipotential. We have to find, that means, the value of V dash. So I will substitute the value of Q in this particular expression. So I will get Q minus Q. I'm referring to this is equal to C. Let me put the value of C. C is known to me and I just need to substitute for Q. So my Q is coming out to be CV dash, and my Q is equal to Q minus CV dash. Q is given. The total charge available to me was 78, right? 78 volts, right? So I know the total charge also which was available to me was 78C, in fact, right? So I can change this also to 78C minus CV dash. That's my Q. If I substitute the value of Q here, I get 78C minus CV dash is equal to C alpha V dash square by 2, and I can eliminate C from all of this. I will get an answer which is 2 7s are 14. This will become 156 minus 2V dash is equal to C is gone. Alpha is known to us. Let's use the value of alpha here, and alpha comes out to be 2 per volt, right? So I'm writing alpha is 2V dash square, and therefore I get 2V dash square minus, okay, I'll bring it on the other side, plus 2V dash minus 156 is equal to 0. So V dash square plus V dash minus 78 is equal to 0, and V dash is equal to minus 1 plus minus 1 minus minus 4 into, so this minus comes from 78 discriminant, and divided by 2 is equal to minus 1 plus minus 1 plus 78 into 4 8s are 32, 312, right? So 312 divided by 2 is equal to minus 1 plus minus 313 divided by 2. This is quite close to 324. I can write this as 18s are something 17.9, maybe 17.8. So minus 1 plus minus 17.8 divided by 2. Quick calculation there is equal to, can't take negative as the potential. So this becomes 16.8 divided by 2 is equal to 2 8s are 8.4 volt each. So both the potentials therefore attain a value of 8.4 volts. Now, if you look into the NCERT solution, on the contrary, what they have done is a bit different. What they've done is they have taken the value of the final potential. They have calculated straight away the value without doing any integration. So if you refer to any other solution, my take is all other solutions are not up to the mark because they are not, utilizing the basic knowledge that you're charging a capacitor at a physical level and you're gradually increasing the potential. So the overall approach to the problem has to be incremental, which means we have to add the charges on top of a capacitor, which is, you can see how the energy gets on the capacitor half. There is a 2 which comes in, which is what I got here also, right? When I charge the capacitor gradually, I also got the same thing. So my answer to this question is not 6 volt, which is what NCERT has done in their answers. I disagree with that. My answer is 8.4 volts to this problem. Right? I hope that you like this. If you have any comments to make or you would like to correct this solution, feel free to write the comments as to where do you think this solution is not correct. Although I think my solution is correct, but I may be wrong also. And you can correct the solution if you want to. Please put your comments. I'm more than happy to, answer you. Thank you very much.